Welcome back to Math 103. This is video number 20 on growth and finance. Great, so we have this long expression for the total value of our account at the end of 10 years. How does that help us get a formula? Well, here is the clever idea. Multiply both sides of the equation by 1.063. Thus, where you had $2,000 times 1.063 to the ninth as the starting term, now you're multiplying it by an extra copy of 1.063. Where you used to have 2,000 times 1.063 to the 8, you now have an extra copy of 1.063, all the way down to the lowest and final term, 2,000 times 1.063 to the 0, that's getting a 1.063 multiplied in. That's the left side of the equation has just been multiplied through by 1.063. The right side is also being multiplied by 1.063, and now you're thinking, so how does that help? All right, let's clean this up a little bit. 1.063 times 1.063 to the ninth, this is one copy of 1.063 times 9 copies of 1.063. Altogether, that's 10 copies of 1.063. Right, so similarly here, we've got now a total of 9 copies, 1 plus the original 8, so 9 copies of 1.063 are being multiplied together here. In our final term of the sum, we used to have 0 copies of 1.063, now times 1 copy of 1.063, in the end that's 1 copy of 1.063. Okay, so we clean things up a bit, we simplify a bit. Our sum of 10 terms starts with 2,000 times 1.063 to the 10, and it continues going with the exponent dropping at every step until it ends with 2,000 times 1.063 to the 1. So this sum looks very much like the original sum, except the exponents have each been increased by 1. And on the right side, instead of future value, we've got future value times 1.063. Right? All this is the result of taking our perfectly good equation for the future value and multiplying both sides by 1.063. If you've never seen this before, and you're wondering how this helps, I don't blame you. So here's what we have now, and then we'll see a very, very clever move. We've got our new equation with slightly higher exponents, and our original equation. The new equation has the exponents running from 10 down to 1. The old equation has the exponents running from 9 down to 0. And on the right side, we've got 1.063 times future value, and in the original equation, it's just future value itself. Now, here's the clever thing. We can subtract the original equation from the new equation. And behold, look what happens. Right? When I take all of these expressions, and I subtract from them all of these expressions, what do I notice? I've got a 2,000 times 1.063 to the n, and I'm subtracting off a 2,000 times 1.063 to the n. Those are gone. Fantastic. I've also got a 2,000 times 1.063 to the 8, and I'm subtracting off, among the things I'm subtracting off, is a copy of exactly that same thing, 2,000 times 1.063 to the 8. So I get to cancel these as well. All the way down the line, I'm getting cancellation galore. There's a 1.063 to the 7 term here that cancels with the corresponding term there. I get cancellation, cancellation, cancellation. This one is canceling with that one. We've got these two terms that are identical with 1.063 squared. I've got cancellation here, between these two terms with 1.063 to the 1, and almost everything cancels, except there is this first term in the new equation that survives the cancellation. There is also this last term in the original equation, which survives the cancellation. On the right sides, there were no cancellations, so we still have the FV times 1.063 from the new equation, and the FV by itself from the old equation that's getting subtracted off. What we have at the end of the day is this $2,000 times 1.063 to the 10 minus this $2,000 times 1.63 to the 0 equals this FV times 1.063 minus that FV. Right? When you subtract one equation from another equation, the result is an equation. Okay, the resulting equation is left side minus left side equals right side minus right side. This leaves us with an equation with one unknown quantity fv. All the rest might be a little messy, but it's all just numbers. And what do we do now? We solve for fv. This is not even that hard at this stage. We've done all the hard work through that crazy cancellation. The first thing to do on the way towards solving is to realize that this 1.063 to the 0 is really just 1. We make that replacement. And although it's not necessary, I'm also going to write a 1 here. This is fv by itself. That's the same as fv times 1. You'll see in a moment why I write it like that. So on the left side, we've got our 2,000 times 1.063 to the 10 minus 2,000 times 1. Okay, no change here. But now, from this stage to the next, I have 1.063 copies of fv minus 1 copy of fv. So 1.063 apples minus 1 apple is 0.063 apples. So I've got, after the subtraction, 0.063 copies of fv. Now we finish solving by dividing both sides of the equation by this 0.063. Right, our job is to solve for fv. That means isolating fv on one side of the equation and just having numbers on the other side. So to isolate fv, we divide by 0.063 on both sides of the equation. The left side becomes this whole expression, so what we had before divided by 0.063. And on the right side, we've just got fv by itself. Before going on to the next video, complete this computation of the future value. Actually compute how much this number is. This is a little bit tricky just in terms of keeping track of parentheses, order of operations. It takes a bit of care to input this correctly into your calculator. After you've done that and found a value, think, does the answer you obtain seem plausible?